Divya, am I audible? Divya, am I audible? Divya?
Yes, sir.
Okay. Yeah. Yeah. பேட்டரி கொடுக்கலையா அவன்? சரி. இதுல இருந்தா சரி பாரு, ஆனா அது திருப்பி வர. Yeah. Shall we get started? Yeah. So previous
Yes, sir.
class we discussed about connector. Okay. So yeah. Okay. So in the previous class, we were discussing about multiplication of a matrix by a scalar, right? So we saw this example, and from here, we also saw the concept of negative of a matrix. So what do you mean by negative of a matrix? If you take a matrix and multiply it with -1, then the new matrix becomes negative of the original matrix, right? So if you take this example, A is equal to 3, 1 minus 5x, then what is the negative of A? -3 minus 1 plus 5 minus x. That's it. So these are the steps that you need to show for the sake of exam. But when you directly write the result, you know what has happened, right? So I'm assuming that you know how to write this. Okay, next. So from this, the concept that comes into picture is the difference of matrices. If suppose A is equal to Aij and B is equal to Bij are two matrices of the same order. If there are two matrices of the same order, and let's say that the order is M cross N, then the difference A minus B is defined as a matrix D, which is given by Dij, so that how the elements are going to be. Okay, just a minute. So when we discuss about the concept of difference of matrices, what happens if we have A is equal to Aij and B is equal to Bij? These are the two matrices with what condition getting satisfied? They both are of the same order, right? Let's say they both are of the same order, which is M cross N. Then the difference A minus B is defined as the matrix D, which is given as Dij, where Dij will satisfy what condition? It will be Aij minus Bij, means the difference between the corresponding elements of matrix A and matrix P for all values of I and J, right? So you can write D is equal to A minus B, or what is the other way of writing? A plus of minus 1 into B. That is the sum of the matrix A and the matrix minus B. So this is how the difference of two matrices is defined. Okay. You can just make a note of the statement. Is it clear? Shall we proceed? Okay. No. Let's discuss this example 7, which is based on the concept of difference of matrices. Okay. Set A has the elements 1, 2, 3, 2, 3, 1. Set B has the elements 3, minus 1, 3, minus 1, 0, 2. Right. Then we need to find 2A minus B. So if you look at A is multiplied with a scalar of 2 and B is multiplied with a scalar of minus 1. Right. So first thing, even before we proceed with this operation, what is that we need to verify? Whether they both are of the same order. So they both are of same order, hence we can proceed. So what is going to be the value of 2A? 2A will be 2, 4, 6, 4, 6, 2. What is going to be the value of B? B is as it is, right? So I'm not writing. So what I will do is I'll write the value of minus B. So what is going to be the value of minus B? It is minus 3, 1, minus 3, 1, 0, minus 2. Okay. Then when you do 2A minus B, what are we going to get? 2, you can directly add it because I already wrote it as minus B. Listen to this carefully. Don't subtract them, directly add them. So 2 minus 3 is minus 1. 4 plus 1 is 5. 6 minus 3 is 3. 4 plus 1, 5. 6. 2 minus 2, 0. So this is going to be the result of 2A minus B. And if you observe 2A minus B will also be of the same order. Right. Shall I proceed? So now let us see the properties of matrix addition. So first thing, it follows commutative law. That is, if I have a matrix A is equal to Aij, B is equal to Bij, they are of the same order, say m cross n, then A plus B is also the same as B plus A. That is what is commutative. Right. So for this, I don't think we need proof, but I'll just explain it. See, if I have two matrices A plus B, what are you going to do? You're going to add the corresponding elements of matrix A to the corresponding elements of matrix B. So when you do that, right? So Aij plus Bij is going to fall into a matrix, right? Can I write this as Aij plus Bij? Right? This Aij and Bij will get will get added, and they will fall into one matrix, right? Now, since these two are going to be numbers or functions, can I say 1 plus 2 is the same as 2 plus 1? Right? Because addition of numbers is going to be commutative. So it is the same as Bij plus Aij. Now you're just going to write the reverse of this. So Bij plus Aij can be written as Bij separately plus Aij. What is the element? This corresponds to matrix B and this corresponds to matrix A. So this is how you start and you get back. So basically what we are doing is you're only adding the numbers inside the matrices. Since the addition of numbers is going to be commutative, same is applicable even for the addition of matrices. Okay. So that is the first property. Second is associative law. So what does associative law speak about? It says A plus B is done first and it is added to C is the same as adding A to B plus C done first. Okay. So for any three matrices, A is equal to Aij, B is equal to Bij, and C is equal to Cij of the same order, say M cross N, then A plus B plus C is the same as A plus of B plus C. Okay. So again, the proof is going to be the same. When you write A plus B plus C, you will put this in the bracket first, right? Plus Cij. Right. Then what will you do? When you expand it, it is going to be Aij plus Bij plus Cij. So the sum of these two is going to be this. So when you add this number and this number, what are you going to get? You will get Aij plus Bij plus Cij. Right. Now you will just write the things in reverse. So if you take the right hand side, then you will write Aij plus Bij plus Cij. That's what is written here. Right. Then what will you do? When you expand it, you will get Aij plus Bij plus Cij. It is going to be the sum of the same numbers. So to put it simple, since you are adding the numbers, A plus B plus C is the same as A plus B plus C. Okay. So it is going to be the associative law. All right. The next is going to be, this is the most important one, this one and this one. Okay. Existence of additive identity. So what do you mean by additive identity? To a number, right? To a number, if you add something, you should get back the number. So what is that you will add? You will add 0. So 0 is called as the additive identity in terms of real numbers. Whereas since we are talking about matrix, what do you mean by existence of additive identity here? It should be a matrix. So what is the matrix that contains all zeros? It's a zero matrix or a null matrix, right? So let A is equal to Aij be a matrix of order M cross N. Then you will define a zero matrix of what order? Of the same order. You cannot write zero matrix of some random order. You always need to write of the same order. Then 0 be the M cross zero matrix of order M cross N, so that A plus 0 is going to be the same as A plus O is going to be the same as O plus A is going to be the same as A itself. Okay. So in other words, what can you say? O is called as the additive identity for matrix addition. Right. Now, what do you mean by additive inverse? So if I have a number 5, I need to add a number here so that I get a 0. What should I do? To a real number, if I talk about the inverse of it, additive inverse of it, then I need to add a number so that the sum of these two numbers is giving me a 0. So what number should I add? So it is basically negative of that real number. In a similar way, when you talk about the existence of additive inverse, if you have a matrix A is equal to Aij of order M cross N, then we'll have another matrix which is going to be negative of A, which is of the same order M cross N, so that you add A to the negative of A, what will you get? You will get a null matrix because these two are matrices. When you add two matrices, you will get a matrix. So A is added, matrix A is added to the negative of itself, or negative of A is added to itself. They're going to get a null matrix. Then this negative of A is also called as the additive inverse of A. So I hope you're clear with what is the difference between additive inverse and additive identity. Identity will generate back the same number. Inverse will generate the 0. Is that clear? So these two are very important. Have it in mind. Just make a note of it. Edidika. But if at all they ask, you know how to write it. I hope you're all making a proper notes out of it. Is it clear? Shall I proceed? To keep your book there. Okay, huh? Done with this? Shall I proceed? Okay, listen. So the next question is about properties of scalar multiplication. Okay. So we understood what is the scalar multiplication. Taking a number, multiplying it with the matrix. When you do that, the scalar gets multiplied with every element in the matrix, right? So if I take a matrix A, which contains the elements Aij, and B contains the elements Bij, these are the two matrices of the same order, say M cross N. And let me say that K and L are scalars. Okay, let me say that K and L are scalars. Then K into A plus B is going to be K into A plus B is going to be Ka plus Kb. So the K will get multiplied with each matrix. It will get multiplied with each matrix, right? Similarly, when you talk about K plus L into A, then K will get multiplied with A plus L will get multiplied with A. So it is going to be Ka plus L into A. The proof is very much similar to what we saw in matrix multiplication. Sorry, matrix addition, right? So if I take K into A plus B, it is going to be K into Aij plus, K into Aij plus Bij. Then what is it going to be? So it is going to be K into Aij plus K into Bij, right? Then what is going to happen? K into Aij can be written as Ka and K into Bij can be written as Kb. So this is the proof for the first one. What about the second one? So if you look at the proof of the second one, right? K plus L into A is going to be equal to K plus L into, in the place of A, you will write it as Aij, right? So K plus L into Aij is going to be equal to, it is going to be equal to K into Aij plus L into Aij, which is again going to be K into, this is going to be A, and L into this is going to be another A. I hope you understood, right? It is basically like distributing that scalar to each. So distributing each scalar to the matrix. That is the meaning. That is the meaning of K plus L into A. So anyways, these two properties are to be remembered. That's it. Done? Okay. See, proof, you can look at your textbooks. Okay. Don't waste your time on writing it now. We have other important topics to handle. Shall I proceed? Right. So let's look at this example number 8. If A is equal to 804 minus 236 and B is equal to 2 minus 2, 4, 2 and minus 5, 1, then find the matrix X such that 2A plus 3X is equal to 5B. So what is 2 into A? It is going to be, directly tell me, 16, 0, 8, minus 4, 6 and 12. Right? Plus, I don't know what is 3x is going to be. So 3 into, I'll do one thing. So what should be the order of the matrix X? It should be 3 cross 2. Right? So can I say it is going to be 3A, 3B, 3C, 3D, 3E, 3F? Can I write it like this? So where I'm taking the matrix X to be A, B, C, D, E, F. Okay. So this should be equal to how much? This should be equal to B. So 2 minus 2, 4, 2 minus 5, 1. Right. Now what should happen? 2a plus 3x is equal to, oh, it is 5b here. So 5 into this thing. So answer will be 10 minus 10, 20, 10 minus 25, 5. So what should I do? Add this element and this element. That should be equal to 10. So how much is that? 16 plus 3a is equal to 10, which implies a is equal to, observe, 10 minus 16 minus 6. So 3a is equal to minus 6. A will be minus 2. Similarly, 0 plus 3b is equal to minus 10, which implies 3b is equal to 10 or b is equal to 10 by 3. Right. Similarly, 3c plus 20, 3c plus 20, sorry, 3c plus 8. 3c plus 8, how much is it? 3c plus 8 is 20, which implies c is equal to 20 minus 8, 12. 12 by 3 is 4. Right. Then what will you have? Minus 4 plus 3d is equal to 10, which implies 3d is equal to 14. D will be equal to 14 divided by 3. Right. Similarly, 6 plus 3e is equal to minus 25, which implies 3e is equal to minus 31. So e will be minus 31 by 3. 12 plus 3f is equal to 5. So f will be equal to 5 minus 12 is minus 7. So it will be minus 7 divided by 3. Do you understand? So what is going to be the matrix X? It is going to be minus 2, 10 by 3, 4, 14 by 3, minus 31 by 3, minus 7 by 3. This will be the answer. Right? So can you check if it is matching with the textbook? Is it matching? Tell me the answer. Minus 10 by 3. 31 by 3 or minus 31 by 3? Minus 31 by 3. Okay. What time did you sleep? You didn't sleep at all. Face wash. You're fine. Okay. Shall I proceed? Right. So let us look at the ninth one. Find x and y if x plus y is equal to 5209, x minus y is equal to 360 minus 1. Okay. So x plus y is equal to 5209. X minus y is equal to 360 minus 1. So what can you do? Can you add both? Can you add both the sides? Right. When you add these two equations in matrices, these are not variables, these are matrices. Remember that. When you add them, what will you get? You will get 2x on left hand side. Right. So x plus x is 2x, y plus or minus y. So they both are additive inverses of each other. Right. So this is going to be equal to, how much will the answer be? 5 plus 3, 8, 8, 0, and 8. So what will be the value of x? X will be equal to half. So this 2 will go to the other side as half into this matrix. So scalar multiplication of matrix. So what should be the answer? 4, 4, 0, 4. Is it clear? Now, when you subtract these two, you will get 2y is equal to, subtract them, 5 minus 3 is 2, 2 minus 6 is minus 4, 0 minus 0 is 0, 9 minus of minus 1 is 10, which implies y is equal to, so it will be half of this value, no? So it is 1, minus 2, 0, and 5. So this is going to be the value of y. Clear? Let me know if I can proceed. Right. So example number 10 is, find the values of x and y from the following equation. So 2 will get multiplied with each term. So you will have 2x, 10, 14, 2y minus 6, plus 3 minus 4, 1, 2. This should be equal to 7, 6, 15, 14. Right? So when you add both, you will have 2x plus 3 is equal to 7, which implies 2x is equal to 4 or x is equal to 2. Similarly, you have 2y minus 6 here, 2 here, add them. 2y minus 6 plus 2 is minus 4 is equal to 14, which implies 2y is equal to 18 and y is equal to 9. So x is equal to 2 and y is equal to 9. Clear? Shall I proceed? Right. So let us see how to solve this problem. Example 11. Two farmers, Ramkishan and Gurcharan Singh, cultivates only 3 varieties of rice, namely Basmati, Permal, and Nora. The sale in rupees of these varieties of rice by both the farmers in the month of September and October are given by the following matrices A and B. So A is the September sales in rupees. So for each variety of rice, the sale value is mentioned 10,000, 20,000, 30,000, 50,000, 30,000, and 10,000. So first row corresponds to Ramkishan and the second row corresponds to Gurcharan Singh. Similarly, if you observe the sales in the month of October, right? So it comes out to be 5,000, 10,000, 6,000 for Ramkishan and 20,000, 10,000, and 10,000 for Gurcharan Singh. Right? This is the data set that is given to us. Now the question is, find the combined sales in September and October for each farmer in each variety. So what is going to be the combined sale? Combined sale is going to be A plus B. So when I do A plus B, how much will be the answer? 15,000, 30,000. So 15, 30, it is going to be 36,000, right? Then it is going to be 70,000. Then it is going to be 40,000 and 20,000. Right, 20,000. Now, this is for whom? This is for Ram Kishan and this is for Guru Charan Singh, right? Now, the next question is find the decrease in sales from September to October. So when they say decrease in sale, you need to calculate A minus B. Am I right? So you're going to calculate A minus B. Here it was 10,000. Here it is 5,000. So how much is the decrease in sale? It is 5,000. 20,000 minus 10,000. It is going to be 10,000. 30,000 minus 6,000. It is going to be 24,000. 50,000 minus 20,000 is going to be 30,000. So 30,000 minus 10,000 is going to be 20,000. 10,000 minus 10,000 is going to be 0. So here there is no decrease in sale. Okay. Okay. So if both farmers receive 2% profit on gross sales, compute the profit for each farmer and for each variety sold in October. If both farmers receive 2% profit on gross sales. So what is gross sales? So A plus B is gross sale. How much is the profit considered to be? 2%. When on gross sales, compute the profit for each farmer and for each variety sold in October. So what should I do? So to each number, I should add 2% of it. Are you able to understand? So basically, it is going to be A plus B is there, no. So the matrix they are expecting is A plus B plus 2% of A plus B. Right. So how much is that going to be? Let's do it directly. Sorry. Compute the problem. Then it is easier. So I thought they asked the gross value. So correction here, listen. This is the gross value A plus B. So on this A plus B, we are expected to calculate what is the profit at a rate of 2%. Compute the profit for each farmer and for each variety sold in October. If both farmers receive 2% profit on gross sales, compute profit for each farmer for each variety sold in October. Okay, then you need to calculate only for this. Yeah. So correction, guys, listen to this. So what we need to calculate is, we need to calculate 2 by 100 of B. So how much is that going to be? So 15 to 2, it is going to be 100. 10,000 by 1,000 is going to be 100. It is going to be 200. 6,000, it is going to be 120. Here, 20,000, it is going to be 400. So 10,000, it is going to be 200. And again at 10,000, it is going to be 200. So this is going to be the profit for Ram Kishan. And this is going to be the profit for Guru Charan Singh. Okay. So is the answer matching with the textbook? Right? Okay. Right. So we'll go to the next important concept, that is matrix multiplication. Okay. So let's take a problem statement here. The question is, suppose Meera and Nadeem, right? Meera and Nadeem are two friends. Meera wants to buy 2 pens and 5 storybooks, while Nadeem needs 8 pens and 10 storybooks. They both go to a shop to inquire about the rates, which are quoted as follows. So in the shop, what are they quoting? Each pen is going to be 5 rupees and each storybook is going to be 50 rupees. Now, having said this, using the basic arithmetic calculation, what is the total amount they need to spend? Right? What is the total amount they need to spend individually? That is, how much money does each need to spend? So for Meera, it is going to be 2 pens into, what is the cost of each pen? 5 plus 5 into 50. So 5 into 50 is 250 plus 10 is going to be rupees 260. What about Nadeem? So what about Nadeem? 8 pens, no, 8 into 5 plus 10. So 10 into 50. So 500 plus 40, it is going to be rupees 540. Right? So this is the way we calculate using the basic arithmetic operation. But the question is, if this data of the number of pens in one matrix, that is the number of pens and storybooks in one matrix, and you can write the cost of each pen and storybook in another matrix, then if you perform an operation called as matrix multiplication, we need to validate whether we are getting the same result or not. So what are we going to do? We will take, so what kind of data set is there in our hand? Second is the cost of each. So when you multiply both and write, you will get the total spent, right? So you need to obtain the same result that we obtained using the arithmetic operation using matrix multiplication. For that, we need to have an idea of how to write it in the matrix format first, right? So how are we going to write it? If you see the matrix representation, first is the requirement, that is a quantity. Then price per piece in rupees and money needed in rupees. So what is the number? 2 pens, 5 storybooks. This is by whom? This is by Meera. And 8 pens and 10 storybooks by Nadeem. So this is by Meera and this is by Nadeem, right? So what is going to be the price per each? It is going to be 5 and 50 respectively. So this is the cost of each pen and there is a cost of each storybook. Is that clear? Now, what are we supposed to do is, so how did we get the answer of 260? What did we actually do? We took this 2 multiplied with 5. We took 5 multiplied with 50. The sum of these two gave us the answer of 260. Right? What did we do? Take this 2 and multiply with 5. Take this 5 and multiply it with 10. Right? And you add them. When you add them, you got the number of 260. Similarly, to obtain this 540, what are we supposed to do? Take this 8 and multiply it with 5 and 10 and multiply it with 50, add them. So when you add them, you will get this 540. Basically, the operation that you performed here is what is called as matrix multiplication. So this is what is called as matrix multiplication. I hope you're able to see the difference between multiplication of a matrix by a scalar and matrix multiplication. Actually, what we did here is called as dot product also. It's called dot product. Okay. So this is an example of multiplication of matrices. So what is that we are able to observe? The main point that we need to observe for matrix multiplication is, see, when it comes to the concept of matrix addition and difference of matrices, what is the important condition that needs to get satisfied? Both the matrices should be of the same order, right? If not, you cannot perform the operations. Now the question is, what should be the condition for matrix multiplication to take place? So first thing, we observe that multiplication of two matrices A and B is possible only when the number of columns in A, how many columns are there? The number of columns in A is equal to the number of rows in B. So number of columns, I'll write it as number of columns in A should be equal to number of rows in B. That should be the first condition. Secondly, what did we do? For getting the elements of the product matrix, there is a product matrix. For getting the elements of the product matrix, we take, what do we take? We take the elements of row A and multiply it with the elements of column B and then add them, right? So we take rows of A and columns of B and multiply them, and then we add them element wise, right? These are the two basic steps that are supposed to be followed in the case of matrix multiplication. So having said this, what is the order of this matrix? It is 2 cross 2. What is the order of this matrix? It is 2 cross 1. So when you multiply these two, what is the order you are getting? You are actually getting 2 cross 1. So how you get is the 2 cross 1, this 2 corresponds to the number of rows of the first matrix. And this 1 corresponds to the number of columns of the second matrix. Okay. And what should be the condition? The number of columns here is equal to the number of rows. If you observe, 2 and 2 are same. So why I'm stressing on this point is here also you have 2 cross 1, here also you have 2 cross 1. You should not get confused. Where does the first 2 come from? It comes from the rows of A. Where does this 1 come from? It comes from the column of B. So the order of the matrix will be, if I take general value, what is going to be the order? If it is M cross N and this is of order N cross P, what will be the order of the product matrix? It will be M cross P. Is the point clear? So this is all about matrix multiplication with an example. Now, let us see what is going to be the definition of it. So we had been seeing the definition in terms of general values, right? Now we'll see. So definition of matrix multiplication says the product of two matrices A and B is defined if the number of columns of A is equal to the number of rows of B. And how is it defined? Let's take the matrix A as Aij of order M cross N, and B is a matrix of order B. Sorry, it is of the order N cross P, and what should be the elements? You will take it as BJK, for instance. Okay, you take it like that, and it should be of the order N cross P. What is most important thing to be managed here? This number and this number should match, right? So A is of order M cross N, B is of order N cross P. Then the product of the matrices A and B is a matrix C of order M cross P, right? So it is going to be of the order M cross P. So I told you what we are supposed to do. You take the elements of the first matrix A in which order? Along row wise, and multiply it with the elements of the second matrix column wise and add them, right? So I can make a note of this. This one. Shall I proceed? Yeah. So we'll do one problem for the day. Right. So if you look at example number 12, we need to find AB if A is given as 6923 and B is given as 260798. What is the first check? This is of order 2 cross 2. This is of order 2 cross 3. The number of columns here should be equal to the number of rows. Since it is matching, there is a possibility of these two matrices to get multiplied. So what is going to be the value of AB? So you take the rows multiplied with columns. So 6 into 2, 12, plus 9 into 7, 63. Similarly, 6 into 6, 36, plus 9 into 9, 81. 6 into 0, 0, plus 9 into 8, 72. 2 into 2 is 4, plus 3 into 7 is 21. 2 into 6 is 12, 3 into 9 is 27. 2 into 0, 0, plus 8 into 3 is 24. So what is going to be the answer? The answer will be 75. So 7, 117, 72, 25. So 27, 37, 39, and here it is going to be 24. So this is going to be the value of AB. So according to matrix multiplication, what should the resultant matrix have the order as? Order should be 2 cross 3. So is this of order 2 cross 3? 2 rows, 3 columns. Right? Here? Yeah. Right. So maybe, yeah, this one alone will do it because here we'll understand that AB is not equal to BA. So for example number 13, so for example number 13, A is equal to 1 minus 2, 3, minus 4, 2, 5, and B is equal to 2, 3, 4, 5, 2, 1. Find AB and BA. So what is going to be the value of AB here? AB will be 1 into 2. So first of all, this is of order 2 cross 3 and this is of order 3 cross 2. Right. So what is AB? AB is 1 into 2 plus minus 2 into 4 plus 3 into 2. Right. 1 into 3 plus minus 10 plus 3. Right. What about this? Minus 8 plus 8 plus 10. What about this one? Minus 12 plus 10 plus 5. So what is the answer going to be? 8 minus 8 is 0. Minus 4. So it is going to be 10. And what about this? Minus 2 plus 5 is going to be 3. Right. So this is going to be the value of AB. Now tell me one thing. Is BA a feasible operation? Is BA a feasible operation? Here you have the matrix of order 3 cross 2 and you have 2 cross 3. So when you have a matrix of order 3 cross 2, which is for B, and for A, which is going to be 2 cross 3, the number of columns here is equal to number of rows. So when I talk about BA, what are we going to get? It will be 2, 3, 4, 5, 2, 1. And you will have 1, minus 2, 3, minus 4, 2, 5. So take the rows, multiply it with the corresponding elements in the column. So 2 into 1, 2 plus minus 12. So minus 4 plus 6. 6 plus 15. 4 minus 20. So 4 minus 20. Yeah. So minus 8 plus 10. 12 plus 25. So what about this? 2 minus 4. Minus 4 plus 2. 6 plus 5. right? So obviously you are expected to get a 3 cross 3 matrix. So 3 cross 3, that is what we got. So what is going to be the answer? It will be -10, -2, 21, -16, +2, 37, -2, -2, and 11. So if you observe in this problem, AB and BA both were feasible and we got a result also. But if you observe, AB is of order 2 cross 2 and BA is of the order 3 cross 3 and AB is not equal to BA. Right? We have proved this. So you able to understand? So in some of the problems, what will happen is sometimes if AB is possible, not necessary that BA is also possible. Sometimes it will not be feasible. The reverse operation will not be feasible. That is why we say matrix multiplication is not commutative. So that is one of the properties of it. I hope you could understand, no? Yeah. Is it clear? Just take a 5-minute break. We'll get started with physics. So I can just stretch and relax. So Divya,
Sir.
we hope it was clear, no?
Yes, sir.
So others are there, who all are there? 1 minute. Yeah, Divya, Hari Raghav, Sai Kalyan. I hope everyone is clear.
Yes, sir.
Okay. Okay. So we'll wind up, guys.
Thank you, sir.
Yeah.